In this video on geometric sequences, also known as geometric progressions, we learn how to solve this exam-style question involving three consecutive terms of a geometric sequence, two of which contain an unknown x that we need to find. And as we'll be seeing, it involves the common ratio formula as well as a quadratic equation. So let's get started. We're told that three consecutive terms of a geometric sequence are x minus 3, 6, and x plus 2. And we're asked to find the possible values of x. Well, to get started, let me move this question to the side to make a bit of space, like so. The trick for solving this type of question comes from the fact that because these three terms are terms of a geometric sequence, indeed we're told that right here, we know that the common ratio r of this sequence must equal to u sub n plus 1 over u sub n. In other words, this result tells us that for our geometric sequence, r equals to u2 divided by u1, but it's also equal to u3 divided by u2, and that's equal to u4 divided by u3, and so on and so forth. And so using this fact alongside the three consecutive terms we're given, we can state that the common ratio r must be equal to 6 divided by x minus 3, so I'll just write that. That's 6 divided by x minus 3. And that has to equal to x plus 2 divided by 6. That's x plus 2 divided by 6. Now, focusing on the equality that I'm boxing right now, we have an equation for the unknown x. Indeed, we can now state that 6 over x minus 3 is equal to x plus 2 over 6. All we have to do now is solve this equation. So let's see, the first thing we'll do here is get rid of the x minus 3 and the 6 that are both placed on the denominators. For that, I multiply both sides by x minus 3, as well as both sides by 6. And if it helps, you can think of that as cross-multiplying. Indeed, that leads to 6 times 6, and I'll just write that, that's 6 times 6 on the left-hand side, which will equal to x minus 3 times x plus 2. And I'll write that here, that's x minus 3 times x plus 2. Now 6 times 6 is 36, so that's 36, and that equals to x squared, that's x squared, and then we'll have negative 3 plus 2, so that's negative 1x, and I'll just write minus x, plus negative 3 times 2, so that's negative 6, and I'll just write minus 6. Finally, subtracting 36 from both sides of this equation leads to 0 equals to x squared minus x minus 42. And we now have a quadratic equation we need to solve to find x. And I'll do that on the right-hand side here. I'll just copy that equation. That was 0 equals to x squared minus x minus 42. Now, we could try and solve this equation by factoring, but I'll go ahead and use the quadratic formula with the discriminant delta. And when doing so, I like to quickly compare this to the generic ax squared plus bx plus c to list the values of each of the coefficients a, b, and c. So looking at this equation here, we'd have a which equals to 1, b which equals to negative 1, and c which equals to negative 42. Okay, so the first thing I do is I calculate the discriminant delta. And remember, that's given by b squared minus 4 times a times c. Now replacing each of the coefficients b, a, and c by their respective values, this turns into negative 1 in parentheses squared minus 4 times 1 times negative 42. That's equal to 1 minus 4 times 1, which is 4, times negative 42, so that's negative 168. Finally, 1 minus negative 168 turns into 1 plus 168, and so delta is equal to 169. Done. Now that I know what delta is, I move on to the second step, in which I solve this equation according to the sign of delta. Now delta is positive, so the equation will have two solutions, and those solutions are given by x equals to negative b plus or minus the square root of delta, all of which is written over 2a. Replacing a, b, and delta by their respective values, this turns into negative 1 plus or minus the square root of 169 over 2 times 1. That becomes 1 plus or minus the square root of 169, which is 13, over 2. And finally, that leads to two possible values for x. Either x will be equal to 1 minus 13 over 2, which equals to negative 12 over 2, and so x would be equal to negative 6. Alternatively, x will be equal to 1 plus 13 over 2, which equals to 14 over 2, so x would be equal to 7. And we're done. We've just found the two possible values for x. Either x equals to negative 6 or x equals to 7. And that's the answer. Now we could of course stop there. Indeed, we've answered the question. But if I were sitting in an exam room, I would like to check that each of these two values of x do indeed lead to a geometric progression. And it takes just a minute, and I'll do that in the upper right-hand corner of the screen here. So let's see, if x equals to negative 6, then these three terms would become negative 6 minus 3, so that would be negative 9. The middle term would still be 6, and the third term would be negative 6 plus 2, so that would be negative 4. And we can see here that we are indeed dealing with a geometric progression, and can convince ourselves of that fact by checking that 6 over negative 9 equals to negative 4 over 6. And it doesn't take us too long to see that both of these are equal to negative 2/3, which would be this sequence's common ratio. Next, if x were equal to 7, then these three terms would become 7 minus 3, so that's 4. The middle term would still be 6, and the third term would be 7 plus 2, which is 9. And again, we can check that this is a geometric progression by making sure that 6 over 4 equals to 9 over 6. And if I quickly do that here, that's 6 over 4 equals to 9 over 6. And looking at these two fractions, it doesn't take too long to see that they're both equal to 3 over 2, which would be the common ratio for this sequence. And there we go. That's how to solve this typical exam-style question involving three consecutive terms of a geometric sequence and an unknown x. And that's it for this tutorial.